Okay, everybody, this is section 5 for day 2. We're working with the sum and difference formulas. We're going to start with a couple warm-up questions just to get you thinking. So we're going to find the exact value of sine of 75. So remember, the idea behind these sum and difference formulas is that we can find the value of things that aren't special values by expressing them with angles that are. So you need to think of, for 75, which is most definitely not a special value, if there's some values that we could use that are special, to be able to either add or subtract to that 75 degrees. So brainstorm a little bit, think about two values that might work for our u and our v. So we talked about using those yesterday. So what two angles could add up to 75? Well, how about a 45-degree angle and then a 30? Now remember, you could definitely do this in radian measure too, but obviously if it gives us to us in degrees, that's a whole lot easier. All right, so let's go ahead and write out the relationship of sine of u plus v here. You have that on your formula sheet. It's sine of u times cosine of v plus cosine of u times sine of v. And you don't have to write this extra step, but I feel like sometimes when people are having trouble transferring one to the other, it's kind of nice just to have that repetition so we know what the formula is. So we're just replacing anywhere we see a u with the 45 degrees and anywhere we see a v with the 30 degrees. Oops. So we're going to go through and make those substitutions. And then once we do that, those are all special value angle measurements. So we can go ahead and write out what each of those special value ratios are. So we know each one of these 4 items. Don't know why I wrote a v there, cosine. So we know each of these as our special value unit circle ratios. We're going to replace for each one of them. So sine of 45 is root 2 over 2. Cosine of 30, square root of 3 over 2. Cosine of 45, root 2 over 2, and sine of 30 is a half. Everything from this point on is just arithmetic. We multiply first and then add. So we're doing the multiplications first. Top, top, bottom, bottom. So square root of 6 over 4 and square root of 2 over 4. Those are not like numerators, but the denominators are common, so I can at least write them as a single fraction. So the advantage here of saying, okay, what is the sine of 75? Being able to write it as square root of 6 plus square root of 2 over 4 is that that's an exact answer. If you type this into your calculator, you'll get a decimal equivalent, but this way we actually have an exact answer for that. So it's a really nice kind of additional way to find these other values that weren't special values to start with. Okay, so the other warm-up I want to do with you is, we didn't talk about a tangent one yesterday with triangles, so I want to be able to do that. So I know there's some given information here that you're going to need to get. This is what we're finding the value for. So one of the things that I always like to start with here is just to realize, what are they asking you for when you do this? What is the formula that they're talking about? It's a difference formula for tangent. So I'm going to go ahead and write out the difference formula for tangent. So that is tangent of u minus tangent of v over 1 plus the tangent of u times the tangent of v. So then I know what I need. Like, what information do I even need about this? Well, I need to know, looks like tangent of both u and v. Well, they didn't give me the tangent values, but they did give me some information. They said, hey, the tangent or the cosine of u is that ratio. And then they gave me some information over here about the sine of v is this ratio. And then they tell me some information about what v actually is as an angle, and they tell me some information about u. So they didn't give me the exact ratio I need, but gosh, if they give me a ratio, what do you actually know? Well, 2 sides of a right triangle. Let's take a look at those triangles and draw them. It says u is between pi over 2 and pi. So pi over 2 is 90 and pi is 180. So think about where that picture would be. So I'm going to go ahead and draw these between pi over 2 and pi. That means this is a quadrant 2 angle. So this is a quadrant 2 triangle. So we're always talking about the reference angle from the x-axis, and it says cosine is 8/17. Remember, SOHCAHTOA here. So cosine is adjacent over hypotenuse. So that means 8 and 17. And now let's talk about the negative. I put it just out front on purpose. So how do we know which one's negative? Well, if you're in quadrant 2, the x is negative. The 17, the hypotenuse, is never negative. So then I would go ahead and just do your Pythagorean theorem here to figure out your y value. So negative 8 squared plus y squared equals 17 squared. We solve for y, and you end up getting plus or minus. It would be 289 minus 64, so 225, square root of 225 would be 15. Since it's in quadrant 2, that's how we decide. It's y, it's positive in quadrant 2. So this other side would be 15. Now I can do anything I want in that triangle. Okay, let's do the same thing for the V triangle. So I'm going to go ahead and draw that one. It says, whoopsie daisy, need to see that. It's 3 pi over 2 to 2 pi. All right, so 3 pi over 2 is down here to 2 pi. That means this is a quadrant 4 angle. So I'm going to go ahead and draw it that way. And this is angle V. And it says sine is 3/5. Well, sine, so katoa, opposite over hypotenuse. That means the opposite side is 3. The hypotenuse is 5. Again, it's negative. Well, if you're in quadrant 4, the only thing that can be negative then is the y. So the 5 is the hypotenuse. That's always positive. Third side there is a 4. Pythagorean theorem, but it's a 3, 4, 5 triangle. All right, well, now you can list anything you want about this scenario. So what we need is tangent of u. So in the u triangle, we need to write what the tangent value is. All right, so let's take a peek at this triangle and see if we can figure out the tangent of u. Opposite over adjacent. So it's 15 over negative 8. So negative 15/8. All right, we also need the tangent of v. So in this triangle, opposite over adjacent would be negative 3/4. And I have all the values I need. Now notice when you do this substitution, you are not substituting for the angle u. I don't know the angle. I know the ratio that represents tangent of u. So I'm actually replacing that entire thing with 15 over negative 8. Minus, same thing here. I'm going to replace this entire thing with the ratio that it's equal to, negative 3/4. And then over 1 plus the product of those two numbers. So 15 over negative 8 times negative 3/4. And then everything from this point on is arithmetic. It's a whole lot of just following order of operations. So let's take a peek at what we can do here. In the numerator, I think I would do, instead of minus and negative, we'll call that plus 3/4. In the denominator, I can go ahead and do some multiplication. So I can multiply across there. So it looks like 1, and this would be minus, minus. So it looks like it's going to end up being negative, negative would be a positive, right? So that would be plus, looks like what? 45 over 32. Okay, so now where would you go from here? Well, in order to do this division, I'm going to have to try to put my numerator together, and I need to put my denominator together. So up on the top, I need a common denominator. So I'm going to go ahead and multiply by 2 top and bottom here. So that would give me negative 15 over 8 plus 6 over 8 for my numerator, which is going to give me a grand total of negative 9 over 8. Down at the bottom, I'm going to think of this 1 as like 1 over 1, and then I'm going to make it 32 over 32 plus 45 over 32. So when I put those together, looks like that would be what, 77 over 32. And then how do you divide two fractions? Well, you multiply by the reciprocal. So negative 9/8 times reciprocal would be 32 over 77. Let's see if we can do some reducing. 8 divides into 32 4 times. So it looks like negative 36/77. So we can actually come up with an exact answer just pulling out the ratios that we need. So I know we talked about those two styles of questions yesterday, but we hadn't done a tangent one, I don't think. So you can see what it looks like. So those where you're given an angle, and you can write it using special value angles, or in this case where you're given triangles, you're given ratios, so we can replace the ratios we need. All right, so we're going to finish up with a couple equation solvings for this day too. I need you to find your example 4. I know they totally messed up in the note-taking guide. They have these weird symbols. Those are supposed to be parentheses. So please rewrite that. It's supposed to be cosine, and just put a parenthesis in there. It's supposed to be x minus pi over 3, and then plus cosine of x plus pi over 3, and that's supposed to be equal to 1, and you're supposed to solve this equation for the x. Well, okay, let's think about this for a second. I probably have a relationship then for each one of these, right? I can use the sum and difference formulas, write everything out. Oop, that's not equal to 0, it's equal to 1. Sorry about that. And try to see if I can get something that works. So if there are like terms I can put together, this is not the distributive property, right? That is not the case. This is a sum or a difference formula that we can write out. So I'm just going to write out what that means. Use the sum formula. This is like your u and your v for the first one. So cosine of x times cosine of pi over 3. If it's a minus, remember in the cosine formula, the signs are opposite. So that would be plus sine of x, sine of pi over 3. All right, plus, that's this plus. Now this is the same thing, but it's a plus in the middle, but still a u and a v. So cosine of x, cosine of pi over 3. But now since this is a plus, this will be minus sine of x, sine of pi over 3. And that's supposed to be equal to 1. Okay, let's watch what happens when we put together our like terms. These terms are opposites. They are going to add to 0. I don't even need to figure anything out. They're one's positive and one's negative. These are both one of each, and they are like terms. So if I have one of them plus one of them, that would give me two of them. So two of these guys are equal to 1. Now, part of this I can actually do. Anything that's a special value, let's do that. So what is cosine of pi over 3? Well, cosine of pi over 3 is a half. So I have 2 times a half times the cosine of x equals 1. Well, 2 times a half is 1, so when is cosine equal to 1? All of that boils down to this really easy statement. So if you recognize it's a sum or difference formula, just use it. All right, so when is cosine 1 for what angle measurement? What value of x? Do the inverse on each side. So inverse cosine of 1, when is cosine 1? Well, that happens at 0. Doesn't happen again until 2 pi. So let's take a look at our domain. It's 0 to 2 pi, but 2 pi is not included. So the only value that we need is the angle 0. So the 0 radians, 0 degrees. So using the sum and difference can help us solve equations as well. So let's do that one more time. Very similar. See if you can give this one a whirl. Maybe pause the video, see if you can see where you would start, and then see if we can solve. All right, so I'm going to just look at a sum formula and a difference formula, u and v for each one of these, and write out those formulas. So I have sine of the first, cosine of the second. In the sine formula, the signs are the same, so that would be a plus. And then we have cosine of the first, sine of the second, plus in the middle, so plus. And we start over again with u and v, so sine of the first, cosine of the second angle, which is 3 pi over 2. Because it's minus, it's going to be subtract. Cosine of the first, and then sine of the second. And that's supposed to be equal to 1 again, and we're doing it in that same interval. Well, it looks like we don't have exactly like terms here. So we're going to have to go through, at least initially, and actually do anything we can. So see if you can go through and circle everything that you know a value for. Or should I say should know a value for, right? Special values. I think I know this. I can do that. I can do that. And I can do that. So let's go through and try all those. So cosine of pi over 2 is 0. So we have sine of u times 0. All right, cosine of u times sine of pi over 2 is 1. Sine of x times, okay, cosine of 3 pi over 2, well, that's 0. And then minus cosine times sine of 3 pi over 2 is negative 1. So we're just finding the values of those special value places. Well, sine of u times 0 is 0, so that's gone. Sine of, or u, did I say u? I did, sorry. I should have said x in both of these. My bad. Those should be x's. I was saying that was my u, so I was replacing it. Please make sure you get those fixed. Sorry about that. Those should all be x's. You're probably like, what is she doing? So x's, right? X is the angle that they're using. So both of these terms multiplied by 0, those are gone. What do we have left? Well, it looks like we have cosine times 1, so that's cosine of x, minus cosine times a negative 1. So negative 1 times cosine would be negative cosine, but it's minus a negative, so that would be plus cosine equals 1. So one of them plus one of them would be 2 cosine of x equals 1. This is a degree 1 equation, so I'm just going to solve for it. Divide by 2. So cosine of x is equal to a half. So the question is then, for what angles x would cosine be a half? Well, that's a 60-degree reference angle, or pi over 3. That's quadrant 1. What else is cosine positive? It's the x. So that would be quadrant 4. So we need the 60-degree reference angle in quadrant 4, which would be 300, or 5 pi over 3. So again, because it just said 0 to 2 pi, I can just answer those. If they had been all values, then they would be plus 3 or plus 2 pi n. So we have some options there for those. All right, so I just wanted to do a couple more just to make sure people were on track here for what's happening. I'm only going to add 4 more questions, so I'm going to have people kind of take a peek. So if you want to pause the video so you can see that, I'm going to scooch down to a little bit so you can see this last question like the rest of it. So we have an error analysis, and then how do you see it? Remember, we can always talk about the graphing approach to these too, to see how these work. So this is the day 2 part, just these last 4. But we're using sum and difference formulas to solve.